Good afternoon, everyone. Welcome to the third session of Chemistry 2K20 webinar series, organized by the Department of Chemistry and IQC of Marthoma College, Chugatara, in association with Kerala State Higher Education Council. Chemistry 2K20 webinar series was inaugurated by Professor Dr. Sabu Thomas, Honorable Vice Chancellor of Mahatma Gandhi University, on 25th November 2020. On that day, Sir has delivered inaugural lecture on the topic Advanced Sustainable Polymeric Materials. The second lecture was delivered by Dr. Vijay Mohan K. Pillai, Professor and Chair Chemistry, ISET Tirupati, on the topic Doing Chemistry in the Time of Pandemic. Today, for the third session, we have Professor Dr. T.S. Anirudhan, BSR Fellow and former Professor, University of Kerala, as our Chief Guest. He has over 36 years of teaching and research experiences and has produced 44 PhDs and has over 300 publications in the national and international peer-reviewed journals. He has contributed over 25 chapters in several books published by various reputed publications. He was ranked among the top scientists in the world in the list prepared by Stanford University, USA, with a worldwide subject rank of 295 globally in the subject area of chemistry engineering. Once again, I welcome all of you to the third session of Chemistry 2K20 webinar series. I now invite Professor Dr. Reina Thomas, our beloved principal, to address us.
Good afternoon. Chief guest of the day, respected Dr. T.S. Anirudhan, College Bursar, Dr. Mathai Joseph, IQAC Coordinator, Dr. Rajiv Thomas, dear participants, faculty and staff members, and dear students, warm good evening. I'm happy and glad that the Department of Chemistry could organize this 5-day webinar, international webinar series, Chemistry 2K20, in association with Kerala State Higher Education Council. As Ansha said, in the inaugural session, we had a wonderful presentation by Professor Sabu Thomas on the topic Advances in the Field of Nanomaterials. And the second session was led by Dr. Vijay Mohan Pillai on the chemistry of daily life with special reference to COVID-19. Today, I'm very glad that we have dear Anirudhan sir with us, a man who had bred chemistry as his life partner, a scholar and academician who is hardworking and has unquenchable zest for chemistry. On behalf of Marthoma College community and the participants of this webinar, let me welcome you, sir, once again with all our heart. Let's have an enriching session with sir. As said in the introduction, sir has received several awards, medals, and prizes in recognition of his contributions to the field of research. The awards include the Andhra University Award and Prize in the year 1997, the Pattabhirama Endowment Medal and Prize 1998, the S. Krishna Iyer Award and Prize 1998, Her Highness the Maharani Sethu Parvati Bhai Award and Prize 1999, Rashtriya Gaurav Award, IFA New Delhi 2005, Sri Chitra Prize 2013, American Chemical Society Fellow Membership Award 2015, and Achievement Award in 2016. He has also received over 25 Best Paper prizes and Best PhD Thesis awards. And in addition to that, last year, he was awarded the UGC BSR Faculty Fellowship for the year 2019, the highest academic recognition that one can aspire for, an achievement whose magnitude reveals itself in the fact that Dr. Anirudhan was the only researcher from the field of chemistry from all over India. And also, recently, he has been positioned as 249 in the Stanford list of researchers or scientists in the field of polymer chemistry, chemical engineering. Congratulations, sir, for you being placed in that position. And I'm very happy that you are with us. Once again, welcome you, sir. The efforts of the Department of Chemistry and Accuracy in organizing this webinar in a very good manner is greatly appreciated. Dear participants, have a great learning experience and interact well with sir. All the best. Thank you.
Thank you, ma'am. We are extremely privileged to have Professor Dr. T.S. Anirudhan, PSF Fellow and former Professor, University of Kerala as our Chief Guest. He is an eminent academician with over 36 years of teaching and research experiences. A successful researcher who is ranked among the top scientists list prepared by the University of Stanford in US. Sir, I welcome you to deliver the main talk.
Okay, thank you. Thank you. So next my presentation, Reina. Okay.
Yes, sir. Yes, you can proceed.
Just wait 1 minute. Okay. Yeah, just yeah, I will present this. Okay. Thank you. Good afternoon, and welcome to all of you to this event. At once, each one. Okay. And before my talk, I congratulate and I express my sincere gratitude to college authorities and especially principal, then manager, IQAC director, then Department of Chemistry, and all other faculty members to organize this type of events. And of course, my career is started in 1987 in Department of Chemistry, University of Kerala. And I think this college is also prestigious college affiliated to University of Kerala. Similarly, I think we have a good alumni in your college, and you have produced a large number of meritorious students or outstanding students. They are working all over the country with a high position. So, and I think once I express my sincere thanks to all of you once again to provide this chance to present my simple topic, functional advanced material for specific application. And of course, regarding my department, our department is also started 1937, is an older department, where our university is also established on the same year, 1937. So our department is a very old department, and we have offering a MSc, MPhil, and PhD programs in chemistry, and we have good reputation, especially this. We have many projects running in our university departments, and faculty and research scholars, they are hardworking. And I even remember that Dr. Reina Thomas is who obtained MPhil and PhD degree under my guidance, even in the early stage. And without a sophisticated instrument at that period, we have only burette and pipette, and we have only one spectrophotometer, cost of 35,000 Bosch and Long. And we have produced PhDs during that period without any sophisticated instruments in our department. Now, department has many sophisticated instruments like XPS X-ray photoelectron spectroscopy, NMR, then scanning electron microscopy, atomic force microscopy, like this, ICP. So most of the instruments that are available in our university departments, and we have provided all these facilities after a small payment from outside students, research scholars working in various institutions. Now, and of course, our faculty members and research scholars also working round the clock. They are hardworking, and they produced. They published a large number of publications. I think, according to my knowledge, we have more than 3,000 publications in international journals, and also we have produced 300 PhDs and near about 800 MPhils and more than that of MSc and MTech dissertations. So I think we have our department activities also in high level, and we frequently organize many seminars and quiz programs like that activities. And our research activities also ranging from, our earlier work is analytical chemistry, now corrosion management and prevention, then coordination chemistry, polymer chemistry, medicinal chemistry, nano chemistry and nanotechnology, then photochemistry, organic synthesis. Like, you may have A to Z research activities in various areas of chemical sciences. Now, with this background, I want to discuss one or two materials that we have fabricated in our laboratory with my research scholars. So I want to move directly to my presentation. I have slides, and you just listen all these, presentation. And after that, we have interactions regarding this. You clear your doubt or you raise your clarification, so that I want to try to clear this. Okay. So I want to directly go to this presentation with the slides. And I have near about 100, maybe 100 slides we have, but still I don't know how much time that we receive for presenting all these slides. But still, so wish you all the best, and I request each one of you to you make this function okay in a grand success, especially through your active participation. So you please raise after presentation you raise your clarification after my presentation. Okay, wish you all the best, and I just to start my presentation. Okay, so. Please wait. I am. slide. ഇത് ഹൈഡ് ചെയ്യാം. ഇതെന്താണ് ഇതിവിടെ കൊടുക്കുക.
Okay, sir, it is visible now.
Yeah, visible now. Okay.
Yes.
Okay, thank you. Okay.
Okay.
I am not expert in this. That is why the problem. Okay. Sorry for taking delay. Now, so I want to introduce a very simple topic today. Title of topic is Advanced Functional Hybrid Material Platform for Specific Application. It's a very simple topic. Okay. And now we move to this. My topic comes under material science and engineering. You know, this material science and engineering includes the development of process for manufacturing useful materials. And after preparing this material, we want to study the structure, properties, and behavior of the materials. Then after spending this material or after utilization of this material, one of the most important things that we want to make research, especially into recycling and environment-friendly disposal of these spent adsorbent. Now, of course, in this particular discipline, we have two groups working in this field are material scientists and material engineers. Of course, you cannot compare this, but their job is entirely different. Material scientists, including myself, prepare the materials and test the mechanical, physical, chemical, and electrical properties of material. And of course, explore how these properties of the material depend on their microstructures. This is very important. And this is what chemists or scientists, they have role for identifying all these properties, and then only they raise their applications and further utilization of the material. Now, next group is engineers. Engineers, of course, they are in high level. They apply their knowledge to select the most appropriate material which we have already prepared, scientists, and manufacturing process for any given specific application. Now, what is the importance of this particular topic? I have my own explanation like this. We must understand how to develop a new product and technologies that will make our life safer, more convenient, more enjoyable, and more sustainable, and also to meet the demands of future. Demands of future means, you know, we have many problems now today. We are living in a critical time. So tomorrow or day after tomorrow, we have our problem become more and more complex. And in order to solve all these problems, and we chemist people can contribute a lot, because we are the chemistry people only to propose remedial measures to solve almost all the problems. We have A to Z problems. And in order to solve these problems, we need very advanced materials, especially for water treatment or you know, this energy crisis. Of course, we are facing energy crisis, so we want to store our energy, transportation of energy, then conversion of one form of energy to another form of energy. Like this, many problems that we have, and almost all these problems, see, one way or other way, associated with chemistry. So we chemist people can propose remedial measures to solve almost all the challenges that we face tomorrow or day after tomorrow. And this is what we need advanced material for wide applications. Now, so of course, the importance of material, you know, we have a historical perspectives also. We have a strong history. Materials are important in the development of civilization. And you know, this our civilization starts even in origin of our human life on Earth. And from there onwards, we associated our ages with material. So ages is named as material which we make utilize at that period, during that period. And you know, in the origin of human life on Earth, usually people make utilize only natural material like stone, clay, skin, and wood. So especially for this material, they make utilize to construct their shelters and you know, catching prey and something like that. So they make utilize all these type of natural material, and that particular age is known as Stone Age. So what I have concluded, you know, this the age at that period is named as the material which we make utilize. After that, 3000 BC started. So at that period, people found copper, and how this particular copper may be converted into a stronger material by adding some metals. And especially, these people make utilize this tin to convert this copper into a very strong material. Nowadays, this type of materials, combination of two materials, metals or materials may be named as alloys. We have different types of alloys after mixing with the different types of metal ions like that. Okay, so even bronze stage we categorize even in 3000 BC, make utilize this copper and tin mixing together, and they have prepared a stronger material, bronze, the Bronze Age. Now after that, even 1200 BC, people make utilize this iron, especially for fabrication of weapons and all this. So usually during that period, when war is started, so they make utilize this iron for preparing their weapons and other type of materials. And that particular age is known as Iron Age. Then even Industrial Revolution comes. At that period, most of the construction of railroads, building of modern infrastructure, especially this Industrial Revolution starts. At that period, people make utilize the mixture of iron and carbon, and nowadays that particular combination known as steel, and that particular age is known as Steel Age. Now we are living in the world of polymers, and now this age is known as polymer age. Without polymer, we cannot imagine the day-to-day life, our applications, and life itself, depends totally on polymers. Now, of course, we have millions and millions of materials available all over the world. So classification of these different types of material itself is a very big problem. And many scientists, they have their own classification. And very simple classification is mineral-based and petroleum-based. Mineral-based materials usually including metals, semiconductors, and ceramics. Our explanation regarding these metals, example, aluminum, magnesium, then gold, osmium, platinum, iridium, all these are categorized as metal because, valence electrons are detached from this atom, and we have ions are formed, and that ions may be spreaded in electron C with, and that electron may be act as a glue, so that ions combine together, and that particular phase is known as nowadays metals. Then semiconductor, of course, we have silicon, germanium, gallium, and arsenic, that type of materials, and of course these involved atoms may be ionizers, and these ions may be shared among themselves by very strong covalent bonds. So sharing of electron between these two ions may be taking place because after formation of ion, they themselves share and form a covalent bonds in semiconductors. Then what about ceramics? Also, atoms, they behave like either positive or negative ions and are bound by various Coulombic forces between them. Example, glass, porcelain, and minerals. So all these are examples of mineral-based materials. Then petroleum-based materials, of course, polymers, and polymers are nothing but, macromolecules, association of large number of monomers. They have repeating units, maybe in a regular fashion they are arranged, and especially based on hydrogen, carbon, and other non-metallic elements like sulfur, vulcanization, all these organized rubbers and all. So, and again, polymers are nowadays classified into synthetic and natural rubbers. Synthetic polymers present very good advantages in especially technological application because of they are highly resistant and they possess good mechanical and thermal properties, especially low weight and inexpensive. Now, natural polymers is another class of these polymers. They have their own advantages, especially they have their own inherent properties like biocompatibility, biodegradability, non-toxicity, adsorption properties, very high adsorption properties, and film forming ability. They have bioadhesion, hydrophilic nature, and in some cases they have both cationic and anionic nature. So we can utilize all these natural materials for wide applications. Then, of course, why functional hybrid material? Why not use directly one single material like cellulose or starch or tin or copper like that? And because of well-established materials such as metals, ceramics, or plastic cannot fulfill all technological requirement for the various new application, because each applications need each material, and all these materials associated with some inherent properties. Without inherent properties, we cannot make utilize all these materials. So what we need is mixing of different types of individual materials together, and there may be the product may be nano composite or hybrid material, depends on their bindings and all this. So functional hybrid material is nothing but constitution of both inorganic and organic components. So you mix together this inorganic and organic component, and your product is hybrid materials. And actually this type of material with the functional group may be considered as a potential platform is for wide applications. Of course, application including optical, microelectronics, transportation, health, energy storage, diagnosis, then housing, environment, and highly relevant area nowadays in a fourth industrial revolutions in that particular area. The most important thing is Internet of Things. So in order to make you for these applications, we need very advanced hybrid materials. And this. So I have already mentioned that these materials are a combination of organic and inorganic components. Of course, inorganic and organic components, they have their own roles. So you just see that what is the role of inorganic component in a mixture containing both inorganic and organic components. So inorganic component enhancing the mechanical and thermal stability, then modulating the refractive index, providing interconnected porous network for sensing and catalytic applications, then contributing specific magnetic, electronic, redox, and electrochemical properties. And these properties may be achieved from the inorganic components, especially clay, these minerals, metals, and that type of inorganic materials. When you mix with organic molecules, organic components like polymers, your hybrid material become very highly specific and having some new properties. That properties maybe you can raise your sound and make you explore that material for a particular applications. And this is what we need in future. Now, similarly, I have already indicated that organic component is also present. What is the role of hybrid material? The role is to modify mechanical properties for the production of films and fibers, then to obtain various geometrical structures, especially for integrated optical applications, to control the porosity and connectivity of networks. Sometimes we need high porosity and sometimes amorphous nature. Sometimes we need crystalline structure. That type of different types of network that we need after fabrication of mixture. So all this coming from these organic contents. And moreover, that your application is based on hydrophilic and hydrophobic nature. So you balance this hydrophilic and hydrophobic character of that particular composite. So and this adjustment or balancing is coming from organic components. Then, of course, classification of hybrid materials, especially we have two families nowadays. Class 1 deals with the hybrid system where organic and inorganic part interact themselves by weak bonds like van der Waals force, electrostatic, or hydrogen bonds. So these weak van der Waals forces actually utilized to binding this organic component and inorganic component. And we have interface. That interface is actually associated with this type of surface energy and all these types. So we make utilize this type of weak van der Waals forces to bind between this organic component and inorganic component. And next come to this class 2 hybrid families are those because of these organic and inorganic, they bind with the strong covalent bonds. They are sharing of electrons or something like that, orbital sharing and everything that comes, and the material is very strong. Now we have anyway. So we have two distinct area in hybrid orbitals. Don't confuse this with the classification, because we have inorganic and organic. So one of the components maybe we can introduce into another component. So if you take organic molecules, very small amount modified inorganic materials. So that type of hybrid materials are known as organics in inorganic, because inorganic material is actually modified by a small addition of small amount of organic molecules. So modification of inorganic content with organic molecules like this and that type of material is known as organic in inorganics. By the addition of organic organic and inorganic phases allowed complementary properties. These two individual components having their own properties, and they mix together and they produce lower density or higher strength hybrid materials. Now, second one is inorganic modified organic materials. In that particular hybrid material categorized as inorganics in organic. Inorganic modifiers such as I have already mentioned that inorganic component like minerals, clay, metals, semiconductors, carbon, ceramic, etc. You can incorporate into organic molecules. And what are the different types of organic molecules here? We have hydrogel, polymers, rock polymers, polysaccharide like starch, cellulose, alginate, then chitin, chitose, and that type of polymers. Organic polymers we have. And you introduce inorganic material, and that type of hybrid, the formation of that hybrid material is categorized as inorganic modified organic material. So these are two types of classification we have. Then usually we have a nano composite. What is the difference between nano composite and hybrid material? You don't confuse this. The term nano composite is used if the combination of organic and inorganic unit together, and we have a final material with the composite properties, because individual properties mixed together, and we have combined synergetic properties that we have obtained, especially in nano composite. But what happens in hybrid material? However, if a new property emerges from intimate mixture, then that material becomes a hybrid. So, nano composite and hybrid materials are mainly differentiate between because of these inherent properties may be raised in nano composite after mixing. But after mixing these two components, new properties with a new phase may be coming, and that particular hybrid that product is known as hybrid materials. We have introduced. Now, research in topic of hybrid material has many challenges like other topics also, because the main challenge is managing to synthesize hybrid material. How to prepare, how to manufacture, how to fabricate this hybrid material with the specific application along with that properties, because specific application always followed by some inherent properties that you want to introduce in your hybrid material. And this is one of the most important challenges, fabrication of hybrid material with specific properties for specific application. Okay, so and of course we have most of the many scientists working in this biodegradable polysaccharide based hybrid material. And what are polysaccharides? Polysaccharides are complex carbohydrate. This we have a monomer. The monomer may be combined together, and we have a macromolecules. Example, this we have starch, cellulose, dextrin, glycogen. All these are polysaccharide, but monomer is a glucose. So large number of glucose combined together and form starch, cellulose, and dextrin. And this polymer formation. And just like another example is agar-agar, then alginate, where monomer is a galactose. And similarly, we have a natural material like chitin, chitose, and where monomer is a glucosamine. So you just why we our research is based on polysaccharide. Polysaccharide is a naturally available materials, and they are non-toxic, less expensive, biodegradable, polyelectrotype formation, because they have both cations and anionic nature, no inflammatory response, then suitable poly and physicochemical properties. All these are inherent properties associated with the polysaccharide, and that is why we utilize this material with modification or adding another components to fabricate new hybrid materials. And these are the alginate, chitin, chitose, and hyaluronic acid, glycogen, dextran, starch, cellulose, all are example of these polysaccharides. Okay, now. We have in our laboratory, we have developed over 200 advanced materials with different functional groups, and especially based on polysaccharides and all naturally available materials, clay and all these minerals and all. And all these materials, of course, we have prepared in our laboratory is utilized for different applications. First one is environment application, including materials for removing oil from sea, because oil spillage, especially in ocean and sea, catching or trapping of oil spillage, stopping of oil spillage is very important. So we have developed a material for catching these oils, especially these currents and waves, and that drastic conditions, especially we utilize our material for removing these oils from ocean. Then removing heavy metals, pesticide, dye, arsenic, fluoride, phosphate, etc., especially from wastewater. So we want to introduce a new material to remove all these type of toxic heavy metals, especially present in wastewater industry and municipal wastewaters. Then especially radioactive materials, we have nuclear industries, they have produced wastewater, and wastewater containing very toxic chemicals like toxic metal ions like uranium, thorium, and cobalt, very dangerous chemical species. So you want to remove all these radioactive materials from your nuclear industry wastewater, and we have developed a large number of several hydride material to remove all these radioactive elements from our industrial wastewaters. Then another application of this material is analytical applications. We have developed many materials, especially for selective separation and quantification of protein, enzyme, and food additives, especially this our melanin and that type of additives that we want to identify and remove. Then we have introduced material for fabrication of different types of sensors, especially for biomolecule, pesticide, protein, food additive, and toxic chemicals present in packing material, etc. So now last application of all this, the material developed in our laboratory is medical application. Especially we have medical, drug carriers, especially stimuli responsive drug, especially pH, temperature, sound, and magnetic field voltage, etc. When we apply externally, so your drug may be leach out from your hybrid material loaded with these different types of anti-cancer drugs or anti-glaucoma drugs. So drug carrier, where drug is released with external stimuli like these different elements. Now we have another, artificial skin patches that we have, in which we have loaded different drugs, so that we utilize these transdermal devices for delivering controlled and targeted delivery of anti-cancer drugs or antibiotics or analgesic or that type of drugs that we can introduce in a particular organs like kidney, liver, and all this. And next type of work is therapeutic contact lens, where we have fabricated different types of contact lens in which we have introduced glaucoma, anti-glaucoma drugs, and we want to utilize this type of material to fabrication of these therapeutic. And these are the research activities that we have. And I just, I have introduced only 2-3 materials before you, so that we finalize this, okay? And first one is, I already mentioned that environmental applications. And this due to these various activities in domestic, industrial, and agricultural field, we have discharged a large amount of wastewater into water bodies like river, lakes, and oceans, and sea. So we want to, before discharging, we want to remove all these different types of chemical species. And so these wastewater is dumped into your water bodies, or even we have 3 components: hydrosphere or atmosphere or lithosphere. All these activities may be totally depleted the environment quality, and beyond the concentration is beyond the self-cleaning capacity of Mother Nature. So we want to treat all these wastewater containing different types of material, pollutants and contaminants. And of course, this is a large spectrum of, we have chemicals, and all these chemicals may be classified into 2 different compartments: organic pollutants and inorganic pollutants. Organic pollutants are pesticide, antibiotics, and dyes, and inorganic pollutants are heavy metals like mercury, cadmium, lead, cobalt, chromium, etc. Then mineral acid like hydrochloric acid, nitric acid, phosphoric acid, sulfuric acid. We have many industries where acid is utilized to as a initial materials, so that mineral acids may be also presented, and base, sodium hydroxide, potassium hydroxide, that type of base, calcium hydroxide, and everything that present in this wastewater is is categorized as inorganic pollutants. Now we want to remove all these different types of materials, toxic substance, and one of the I want to introduce. We have prepared a large number of materials for different treatment. We have produced material for removing pesticide, dyes, and heavy metals. Individually, we have selective materials for removing all these. Now I want to introduce only one or two materials which we want to make utilize for the removal of arsenic from wastewater. Why arsenic? Nowadays, this one of the most toxic chemicals, arsenic, and it's widely dispersed in the environment, where it is introduced from various human activities such as mining waste, petroleum refining, sewage sludge, then pesticide, fertilizer also associated with this arsenic. So when you inject all this industry wastewater in your water bodies, of course, long-term uptake of arsenic contaminated, especially causes liver, lung, kidney, bladder, and skin and nerve tissue injuries. And according to 2001 US Environmental Protection Agency published a new standard level 0.01 milligram per liter arsenic concentration. Beyond that, we have problems. And what is the latest report? Over 70 million people in Bangladesh and in other region, Indian subcontinents are routinely exposed to these arsenic poisons through drinking of groundwater. Arsenic poison through groundwater also observed in China, Mongolia in China, and Japan. So so that we want to remove this arsenic before discharge of this wastewater directly into the water bodies. And we have prepared a material based on cellulose. I have already mentioned that cellulose is a biopolymer material coming from derived from various sources like plant, bacteria. We want to extract even bacteria, cellulose from plants, bacteria, then algae, animals, and like this. We have different sources for cellulose. And you just see the structure of cellulose. Why cellulose? Cellulose is this having a structure C6H10O5N. This and natural abundant annual production of cellulose is estimated to be 10 raised to 11 to 10 raised to 12 ton per annum. So this cellulose is easily available with no cost from the nature. So why not we utilize this cellulose, especially extracted from plant materials? And this is why we are concentrated in cellulose. And moreover, that as a chemist, you just see the structure of cellulose. We have different types of OH, alcoholic OH group, primary OH group, then secondary OH group, and we have acetyl groups. And like this, many different types of alcoholic OH group and functional groups. And this monomer is a glucose, but still this monomer is two. This structure containing two glucose because of this alternating 180-degree flip. So every second unit, we have a primary alcoholic OH group is in alternate site. So, and this alternate arrangement of this primary alcoholic OH with 180-degree flipping of each second glucose unit is nowadays known as this two glucose unit together in 180 flipping with alternate, OH, primary OH group. What is nowadays known as syntactic stereoisomers. So these type of isomers exist in cellulose, and that is why nowadays glucose is not a monomer of cellulose. So what is the monomer of cellulose is cellobiose, because two glucose unit combined together, and they have syntactic arrangement, 180-degree flipping, and this two glucose unit together is known as cellobiose. And tomorrow onwards, just remember that monomer of cellulose is not glucose, but monomer is a cellobiose, because of two glucose units combined together in 180-degree flipping. Now, advantages of cellulose is again, this ability to absorb moisture, high thermal stability, low density, low cost, high strength and durability. Like this, many inherent properties that we have associated in our cellulose. That is why this cellulose is utilized to wide applications. So find applications in many spheres, modern industry, including to make paper, cellophane, then textile, explosive, and other products. Cellulose derivatives. We want to modify cellulose after introducing some functional group, and final product may be utilized as a chromatographic application, because we want to fabricate ion exchangers, cation exchanger, strong cation exchanger, weak cation exchanger, or strong anionic exchanger, weak anionic exchanger. Like this, we have different types of anion exchangers can be utilized, can be fabricated from cellulose. Then especially nowadays we utilize this cellulose for making artificial temporary skin for burns and wounds, then dental artificial blood vessel, micro nerve surgery, DNA separation, electronic paper, then light emitting diode, and fuel cell membrane. So wide application that we have from this cellulose, and that is why we also utilize this cellulose. And you see this picture. Cellulose is coming from plant, and the plant cell wall is a structure of this plant cell wall. We have middle lamella, primary cell wall, and plasma membrane, and there are large number of chemicals present inside this plant material: pectin, lignin, soluble tannin, hemicellulose, and you see this part is known as cellulose. Cellulose is present as a microfibril. So we want to remove this cellulose from plant material after chemical treatment. And we have, anyway, you cannot directly utilize this cellulose, because cellulose associated with a large number of drawbacks or limitations, and limitations ranging from pure dimensional stability, lack of antimicrobial property, low binding capacity to protein, pure mechanical strength, lack of thermoplasticity, pure crease resistance. Like this, we have different, drawbacks, large number of drawbacks that we have associated in cellulose. So we want to modify our material after rectifying all these limitations. And we have for the time being, I have one material that I have prepared from this plant material. We have sawdust, waste from sawmills. Sawdust associated with different types of other chemicals, hemicellulose, cellulose, pectin, tannin, lignin, etc. So we want to remove all undesired or unwanted type of chemicals from this material, and we want to extract cellulose. So how to extract this cellulose from plant material which containing large number of other chemicals? So first you treat with this 10% sulfuric acid, followed by sodium peroxide, then hydrogen peroxide for removing color matter and all this. And so that product is cellulose, and cellulose is again converted into nanocellulose by simple treatment with sulfuric acid, because cellulose containing amorphous and crystalline phase. Usually engineer people utilize crystalline state cellulose, so we want to prepare crystalline cellulose after eliminating your amorphous phase. So how to remove amorphous from cellulose? You treat with any acids, especially 50% sulfuric acid is sufficient to eliminate your amorphous phase present in cellulose. So your final product is 100% crystalline nature, and that crystalline nature cellulose is known as nanocellulose. Then you see this nanocellulose is treated with ferric chloride and ferrous sulfate, so that you can introduce iron magnetic properties inside this nanocellulose. After introducing your magnetic properties in your nanocellulose, you can treat with any monomers, especially methyl methacrylic acid or vinyl sulfonic acid. All these are monomers containing different types of functional groups. So our idea is to introduce fabricate one particular material with the different fingers. Fingers means reaction sites. So here you see this iron loaded nanocellulose is further treated with monomers like methacrylic acid or vinyl sulfonic acid, containing different types of acid group, COH group, sulfonic acid group. That type of group is that we want to introduce. So likely in that way you can utilize different that type of monomers to graft on the surface of your iron treated or magnetic nanocellulose. So here I utilize free radical mechanism. So free radical mechanism is one of the most important methods to graft for grafting copolymerization. So we make utilize this potassium persulfate as an initiator, and on the most important property coming from this things is, once you introduce an initiator, that initiator itself is decomposes into fragmentation, and we have a sulfate group is formed, and this sulfate is absorb or extract one hydrogen atom from this cellulose, because cellulose containing primary alcoholic OH group and secondary alcoholic OH group. Usually this primary alcoholic OH group associated in cellulose is highly reactive. So these these highly reactive radicals like HSO4 or sulfate negative radicals absorb one hydrogen atom, remove one hydrogen atom from this cellulose, primary alcoholic OH group of the cellulose. Your product is macro radicals like cellulose O dot. And this macro radical is highly reactive, then that macro radical may be reactive with your monomer like methacrylic acid, vinyl sulfonic acid in presence of a cross-linking agent, so that your product is having an interpenetrating network or a polymer network. So you have a cavities or porosity, you can improve with your choice of your degree of that quantity of cross-linking or different types of cross-linking that you can make utilize to improve the properties of your material. Now, this you can see this material. We have sulfonyl group, COH group, and so we have different ionization potential. Different pH value we have, pK value we have. So with two different or more than two different pK value, what is advantages of this different pK value associated with your material? You can make utilize this material after ionization. Ionization means sulfonyl group ionizes, and we have a sulfonate negative ions after this hydrogen is eliminated. Similarly, we have a carboxylate group. So what I have concluded, after ionization or at a particular pH, your functional group may be ionizes, and we have a resonance structure. Sulfonate they themselves resonate, and carboxylic group also themselves resonate with the different pK values or different pH. Especially highly acidic medium may be pH 3.5, or your carboxylic group may be ionizes at a particular pH 4.5 or 5 or 5.5. So what I have concluded, your ionization pH for ionization is different, so that accordingly you can monitor this pK value with adjustment of your pH value, so that you can make utilize this material for selective separation of I make utilize this material for removing or separation of hemoglobin from myoglobin or serum. Like that, we have oxyhemoglobin, different types of oxyhemoglobin, and this material is highly selective for hemoglobin, especially from mixture of myoglobin and hemoglobin. So you can separate even 99% separation may be achieved by using this particular material, only because of two acidic group having two different ionization potential, or we have a 2 pK value. So you can adjust this pH value for your protein, create a selectivity inside this network, and that will help for removing this particular proteins from a mixture of proteins. Okay, now my work is hybrid material, so I have again fabricated a very advanced material, and that material is named as iron 3 coordinated amino functionalized polyglycerol methacrylate grafted titanium oxide densified cellulose. And what is the importance of this particular material? I have already mentioned that we have a big problem that associated in our environment to remove this arsenic 3 and arsenic 5 together. And I think we have, of course, if you go through the literature, there are a large number of materials available for removing this arsenic 3 and arsenic from wastewater. The problem is, this efficiency may be sometimes, then regeneration and recycling of material is another problem. So our material, so one of the most important problems that we face is we have introduced a new recyclable material. You can utilize this material after treating your wastewater several times without losing the efficiency of the material. This is what we need. So actually, we want to prepare an ionic strong or weak ion exchanges to remove this because arsenic and arsenic 3 and arsenic 5 exist as oxyanions, arsenate anions or arsenate anion. So the oxyanionic species can be removed by a strong anionic exchanger. So our idea is to prepare a strong anionic exchanger to remove arsenic 3 and arsenic 5, which are existing oxyanionic species in wastewater with acidic, sometimes acidic media or basic media. So we want to introduce that type of stable material because your wastewater is acidic or basic in nature. So when you treat it with this, your material with acidic wastewater, your material may be damaged. So this is the problem that we face in our nowadays material reported in the literature. And we have introduced this material with high efficiency, and we can repeatedly use several times for removing this arsenic and arsenic 5 from any industrial wastewater associated with this arsenic. So what is the how you prepare this iron? It's very complex in nature. First you convert this cellulose into cellulose candidate. How you prepare a cellulose candidate? Very simple, I think. Cellulose candidate was first prepared by reacting 20 gram sodium hydroxide treated cellulose with 10 ml carbon disulfide. So once you prepare this cellulose candidate after treating with carbon disulfide in presence of sodium hydroxide, your product is cellulose candidate, and this cellulose candidate is further treated with rutile. You make utilize even anatase or glucose, but we have already checked that within this three form rutile allotropy is a very good thing. Material, so product, so that we make utilize this rutile to introduce this titanium inside this material. And this mixture is further dispersed in chlorobenzene and pump oil, so that we have a paste material, and that again further washed and with benzene and methanol, and product is again washed with acetic acid and ethanol. Then again, this the product and finally heated at 60 degree for 6 hours. And your product is what is that product is known as densified cellulose. Simply densified cellulose, because we have introduced both titanium and iron inside this cellulose, and we have encapsulated with this polymer, and this polymer containing fingers or hands with the different types of reaction sites. And you see this very simple. We have a cellulose extracted from plant material, introduce a titanium. Earlier I have already mentioned that first you convert a cellulose candidate treated with rutile, and we have a titanium incorporated densified cellulose, and further react with any monomer, just like glycidyl methacrylate or methylene bisacrylamide cross-linking, and your product is having an epoxide ring. Why I introduced this epoxide ring? Epoxide ring is always highly reactive. You can introduce any functional group. You can move from this material to cation or anionic nature. And you see this, we have treated with this. We want to break this epoxide ring after introducing a chemicals amination, transmutation reactions. You can make utilize any different types of amine containing groups. So we have hexamethyl tetramine or even diethylamine. Like that, you can introduce an amino group. So amine containing chemicals. So what is the reaction? We have an OH group and we have an amino group is introduced. And further treated with iron in presence of HCl. What is the structure of this? This is a very hexacoordinated iron is linked with this titanium loaded material. And this material is, this is a very fantastic material. Having, we have iron is already saturated with coordination with OH ions from your that is aldehyde. Epoxide ring. And we have OH, then nitrogen may be coordinated with iron. Here also we have, so two molecules may be combined together, and the unsaturation, two unsaturation may be saturated with chlorine ions with from HCl. So you can, this chloride ion is loosely bound with this iron linkage. So iron chloride linkage is very weak, and this material is act as a anion exchanger. So you can replace this chlorine with your arsenate or arsenic 5 or arsenic 3. Simple ion exchange. So when you treat it with this material with your wastewater containing arsenate, this chloride may be replaces with the arsenate ions, and again you can treat it with HCl. So arsenate already dissolved from your material. You can make utilize this material even 100 times that without losing efficiency of this material. This is what advantages of this material. So we make utilize this. What is the importance of this material? We have make utilize this simple cellulose available from nature, and we introduce polymers, grafted copolymers, and finally we introduce some fingers and hands, especially reaction sites. You can introduce many different types of functional group in cellulose. And you see, the next one is similarly you can see, I have already mentioned that this titanium densified cellulose is treated with different types of amine. So this is an epoxide ring. As earlier we have introduced an epoxide ring, and these epoxide rings may be bright with this amine group. So we have introduced an amine groups. You see, there are large number of amine groups that we have introduced, NH, and all these. So we have, this is coming from hexamethylene, 1, 2, 3, 4, 5, 6. So hexamethylene tetramine, hexamethylene tetramine treated with this epoxide introduced your densified cellulose. Your product is see the interesting picture. Sorry, this picture. You see, we have a large number of quaternary salts that we have, so that you can exchange this iodide or chloride ion from this material with arsenate ions. So this is another material that we have introduced for removal of arsenic. And here, what is the difference between this material and the earlier material? The efficiency of what is how you measure the efficiency of the material. Efficiency of the material is especially quantified milliequivalents per gram. First one is our ion exchange capacity is 1.7 or 1.8 milliequivalents per gram. Here this is 3.3 milliequivalents per gram. This is one of the first material that we have reported the highest ion exchange capacity. 3.4 means very high efficiency. So because of this large number of functional group, we have large number of functional group we have. These iodide ions may be replaced simultaneously. 3.3 milligram arsenate per gram. So you just remember this, okay? And we have studied all these things, and we have what is the absorption efficiency? 1 gram may be removed 108 milligram arsenate ions from your wastewater. This is a good adsorbent with high efficiency compared with the reported material, maybe less than 20, 25 milligram. But our material is 108 milligram may be removed from wastewater containing 1 liter. Okay, now. Another problem that we face is radioactive pollution. I have already mentioned that thorium, uranium, and cobalt radioactive material present in wastewater is very dangerous. They emit radiation, ionization radius like alpha rays, gamma rays, alpha beta particles penetrate all these rays through living tissue, and we have ion pairs are formed. And what is the mechanism of this toxicity of this thorium, uranium, and cobalt? When when this radiation penetrates into living tissue containing large quantity of water, and you see this when water is bombarded with this irradiated with this gamma rays or alpha beta radicals, or usually ionizing radiations. When this water molecule is irradiated with this type of radiation coming from your radioactive materials, what happens? One electron from this outer orbit may be knocked out from these water molecules, and so that this ejected electron from one single water molecules after irradiation with your ionization radiation coming from your radioactive materials, especially in your tissue containing water molecules. So these ejected electron from your water molecules may be attack another water molecule. This is one of the important mechanisms that already raised by many scientists. So what happens here? one ejected electron from already earlier water molecules may be bombarded with another water molecules, and these water molecules may be split up into large number of different types of ions having positive charge or negative charge, or both negative and positive charge. Sometimes these positive and negative charge, they themselves combine to form ion pairs, and these ion pairs sometimes may be very dangerous compared with your individual charged particles. So finally, I want to conclude like this. So there are large number of free radicals formed after attacking your the ejected electron from first water molecule to second water molecules, and these second water molecules may be dissociated into maybe 20-25 different highly reactive radicals and ion pairs may be formed. What is the limitation or drawback of this radical? Free radicals occurs, we know this destroy living cell and make them function abnormally. And we have already explained the mechanism of this. These ion pairs or free radicals may be destroy your proteins containing SH groups, sulfhydryl groups, and so that your proteins may not be working. And this each protein having its own role in our human any living species, and each protein may be having folded structures, and with these folded structures they have their own job. So each protein we have many hundreds of proteins available in our living species, living body. So, and these proteins, each protein is having its own function. So the function of these proteins may be destroyed after interaction with these radicals, and they break this sulfur hydrogen sulfur bond associated in your protein. Now next mechanism is very important also. We have DNA structure. DNA having 4 bases: adenine, cytosine, then guanine and thymine. What is the difference? What is the this comparison of this group, basic groups? We have thymine have a loose bond binding of this what is that backbone with this thymine is weak. So these highly reactive radicals may be break this bond, and thymine may be leach out from this DNA structure, and so that your DNA structure may be scrambled or damaged, so that genetic codes is even in next generation may be affected. And this is what explain the mutation of this your cell. So that the mechanism, the explanation is the breaking of your thymine bond with your backbone of your DNA structure, so that your DNA that damage of DNA structure may be, and so that the genetic code may be changed in next, maybe move to generation. Okay, this is the how to remove this uranium or thorium or your cobalt radioactive. So we have introduced molecular imprinting polymers. So the mechanism of this molecular fabrication of molecularly imprinted polymers, abbreviated as MIPs. In chemistry, molecular imprinting is a technique to create template-shaped cavities in polymer matrices with the memory of the template molecule. Template is here you want to remove uranyl ion or thorium oxide or thorium or cobalt. So these are the template. If you want to remove pesticide or your dyes, and that chemical is generally known as template. So you want to remove template. So how to remove this template from your wastewater or your blood sample or your urine sample? So we want to introduce this relatively new technology, even introduced in 1970 by well-known scientists. So the mechanism of our fabrication of this molecular imprinting polymers is very simple. We have selected different types of monomer, and the selection of this monomer, here you see green, red and blue, different types of monomer with a different functional group. Selection of this group is totally depends on your template, whether it is a pesticide or herbicide or some other biomolecules like protein, hemoglobin, cholesterol or explosive, whatever it comes. So these particular chemicals which we want to identify or you want to separate, remove that particular chemicals having a particular structure. With this structure, you can select different types of monomers and cross-linker. So that what happens when you mix together this monomer and template? Here you take an example, uranyl ions as a template. So we have select different types of monomers accordingly, then mix together, and you apply an experimental condition, so that through self-assembly, your mixture is formed like this. Template inside, and we have a monomer. They have self-assembled, and we have what is nowadays known as pre-polymerization complex is formed with the template and different types of monomer with the linker. Okay, so and this pre-polymerization complex with the template, you again polymerize with a suitable polymer, so that we have a network in which inside we have introduced this pre-polymerization pre-polymer complex. So pre-polymer complex, when treated with suitable polymers, so your product is actually this pre-polymer is inside that network of your newly fabricated polymer. And of course, this is a template. Okay, so you want to remove this template from this pre-polymerization complex from the network, and we make utilize a suitable solvent extractant, so that that template only remove, and we have an image inside this. We have a particular shape where you see that shape is this particular shape. This is you just imagine that this template is inside this. Okay, so we have a cavity or an image or shape that we have introduced after removing or leaching this template. So this is the technique that we have introduced to fabricate this. So, and this type of polymer molecular imprinting technology, we make utilize, even you can identify steroid to even explosive, trinitro-toluene, TNT, and all this. Nowadays, MIPs are prepared for identifying and quantifying different types of chemicals. Now, I have also prepared different types of polymer imprinting, molecular imprinting polymers, and here you see this is the another schematic representation, because here we have if you make utilize a weak van der Waals forces, you can make utilize solvent to extract this solvent. So that type of product is non-covalent imprinting, and you have a covalent bonding, because your chemical synthesis also here self-assembly, weak van der Waals forces is involved, so you simply make utilize a solvent to extract your template. But here, when you make utilize chemical forces or chemical reaction, we have a strong bond between this template and your monomers. So we want chemical cleavage. So we need strong chemicals to leach out your template. So usually scientists prefer this non-covalent imprinting technology because of the interaction is weak van der Waals. You make utilize very simple solvents to extract this. And so what happens here? Then when this material, when you introduce a solution containing your template, that template only penetrate and inside accumulate inside this material, because we have create a shadow of that particular template. So whenever this after leaching your template and you introduce this material in any sample containing that template may be even in presence of hundreds and hundreds of other chemicals, that template only accommodate in that particular cavity, because that cavity having a shape similar to that this template. And this is the techniques that we have introduced. And here also we have make utilize. We have started with the cellulose with the primary OH group is the alcoholic OH group, and we have vinyl trihydroxysilylation, silylation with the vinyl trihydroxysilane. So we have introduced a reactive vinyl group. So we can introduce initiator, so that this become a free radical, macro radicals, and we have introduced different types of polymers. So this is the what advantages of this silylation. And this silylated cellulose is okay. You keep it this first step. Then I have already mentioned that we want to prepare a pre-polymer complex. Here we make utilize a monomer like 4-vinyl pyridine, and your template is uranyl nitrate. And in presence of 2-methoxyethanol, we have a pre-polymer complex. You see, we have uranyl nitrate interact with your monomer with the self-assembly. Here we have a weak van der Waals forces. You can break this bond even with solvents. So this is a pre-polymerization complex. Further treated with polymers, and we have a polymer network inside which we have uranyl nitrate template, and you can remove this uranyl nitrate with 2 molar HCl, 2 mol per liter HCl, and you have a cavity of similar to uranyl nitrate, because we have a particular shape of this uranium. You know the structure of uranyl nitrate, how this uranyl actually exists inside this cavity, and so that cavity whenever you introduce this imprint in a uranium only, so hello.
Sir.
Hello, sir.
How much time that again we have? Time?
Sir, up to 4 o'clock.
Yeah?
Up to 4 o'clock.
4 o'clock. So I just take another 2-3 material. Okay, we move immediately. Okay, thank you. So I move to that next. So I have already. I want to introduce 3 different types of material. One is the environment application to remove heavy toxic chemicals from wastewater or water bodies. And now I want to move here medical application. Okay, so I want to prepare a large number of materials in our laboratory with my colleagues, research scholars, so that I just move to this medical application. 1 or 2 materials that I want to introduce immediately within 5 or 10 minutes. Okay, so wait. Then what is a drug delivery systems? Okay, so a drug delivery system is defined as formulation or a device that enable the introduction of a therapeutic substance in the body in a controlled manner. In a controlled manner means a particular dose that you want to introduce, especially anti-cancer drug or antibiotic or analgesic. So insulin even you can introduce insulin for a diabetic patient. Instead of injection, you can orally take this insulin through a carrier. So we have also introduced a new material to orally introduce this insulin in our body. After eliminating these intravenous injections, because of this pain is a big problem nowadays. So you can introduce even insulin through your orally by using a drug delivery carrier. And this is the idea that we have. So okay, now we moved. So there are large different types of drug carriers we have. So what is drug carrier? A particular vehicle which carry a particular drug, and it will introduce it in a particular organ, or especially anti-tumor cells to destroy these cells. Okay, so we have liver cancer, colon cancer, kidney problems, and all these. So we have different organs that we have, and we want to introduce a drug in that particular organs. So this is a very big problem that we face. We have and beyond that, we introduce a targeted ligand to this drug carrier, so that each targeted ligand may be associated with a receptor. If you take a breast cancer cancer cell, so your drug may be introduced into that particular site and that particular receptor that we have. So in order to reach that particular receptor, we have considered that target molecules, target ligands also. So that I will come here. Now you see we have different types of drug carrier. We have hydrogels, micelles, and liquid crystals, supramoleculars, nano capsule, nano spheres, multifunctional, then polyelectrodes. Different types of drug carrier nowadays is available. In our lab, my research scholars is also fabricated almost all these different types of drug carrier, including hydrogels, micelles, and liquid crystal supramolecules, and polyelectrolytes. Different types of drug carriers that I have introduced in our laboratory. Okay, so I want to introduce only 2-3 drug. We have that. We have polymeric drug delivery system. I have introduced 2 to 3 polymer network. There are different types of polymer network: diffuser controlled DDS, chemically controlled, water. So what happens? Water penetrating controlled. Then responsive smart polymer control. I am just I interested in response smart control for the time being. Avoid the other 3. So what is a stimuli responsive drug delivery system? Polymeric material that respond to a stimulus are often called smart or intelligent due to their intrinsic ability to alter their physical or chemical properties. There are many responsive elements that can be incorporated in synthetic material or modified polymers. Once again, I want to explain this. We have different stimuli, external stimuli like pH, temperature, light, biomolecules, magnetic, ultrasound. What is this stimuli? When you encapsulate, when you load your drug in a carrier, and when you take that drug carrier along with the drug inside your cell, tumor cell, when you apply an external force like pH, temperature, or ultrasound, your drug may be leach out from this drug-loaded drug carrier. How? Because this stimuli, this external factors may be sufficient to open the door or windows so that your drug may be leach out from the drug-loaded drug carrier in that particular anti-cancer tumor cells. Especially your carrier having a targeted ligand. That ligand may be sufficient to move your carry your drug carrier to that particular cancer cell, because that cell is associated with the receptor. That receptor may be highly sensitive to this particular targeted ligand. You find out that targeted ligand accordingly. So selection of targeted ligands which are bind to this drug carrier, then only your drug carrier may be moved to that particular organs having that receptor. So after reaction with the receptor with this targeted ligands, your drug may be there, but still you externally you apply an ultrasound or magnetic field, then only your window, we have a gate inside this. So we have introduced a gate inside this drug carrier. Then after external application of this external force, maybe temperature, maybe light, suitable wavelength with thermal both, or simultaneously you can utilize sound and temperature or light, whatever it comes. Okay, so the advantages of this stimuli may be, stimuli is open your windows, doors, so that your drug may be leach out, breaking of your bonds, and your material may be degraded, biodegradable, so that your material may be decomposed into fragments, and your drug may be leach out, and that drug may be reach your tumor cells. Okay, so that further mechanism may be explained later. Then this is the target molecules. We have a drug carrier. Then a drug is introduced into this nano carrier, and with the target molecule. So this is the target molecules. And this target, what is the advantages of this target molecule? I already explained that. It will react with the receptor of that tumor cell, and after that you are breaking you apply an external stimuli, your material may be damaged, window may be open, then drug may be released immediately with a particular pH, and that fluid pH maybe we can make utilize buffer solutions, and we have blood pH or stomach pH, intestine pH, and all these. That is a pH stimuli. You can make utilize even stomach, maybe your drug may be trapped inside this material in stomach. When it enter into intestine having a different pH, that pH may be externally stimulate, and your drug may be leach out after breaking your drug carrier even in intestine. Okay, now you see here what happens. I already explained this. This is a receptor. This is a tumor cell. Okay, here receptor we have, and your drug carrier is you see nano carrier, and you have introduced this drug, and we have a what is this actively targeted nano medicine. So just to see, we have a targeted ligand. This targeted ligand is also bind with this drug carrier, and this ligand may be react with your receptor. And after breaking, breaking is this molecule, drug molecules may be leach out, and this is a cancer cell, and react with your cancer cell with this. So it's an anti-cancer drug, okay? And this is the mechanism of our targeted drug delivery systems, okay? And here what happens? We have introduced a polyelectrolyte complexes to deliver different types of drugs. And what is the mechanism of this? So we have a substrate where you have introduced both cationic layer and anionic layer, so that you have introduced a drug inside this layer by layer assembly. So we have cationic layer and anionic layer. We have a cavity layer. We have a cavities inside this layer, and we make utilize these cavities to introduce our drug. And this type of drug carrier is known as polyelectrolyte drug delivery systems, where we have a positive layer and a negative layer. Inside, in between, we have a drug, so that we make utilize external stimuli, so that your layer structure may be damaged, so that your drug may be released immediately to that particular organs. See, I have introduced one more material. The chitosan. Chitosan is prepared from chitin. I take another 2-3 minutes because I have a large number of slides. I reach only 15 or 20 slides. So chitosan, this one of the other important natural materials prepared from cellulose. Chitin. Chitin is the second most abundant polysaccharide in nature after cellulose, and it is also available in large quantities, estimated as 10⁹ to 10⁻11 tons per annum that we have produced. Even you can, with no cost, you can easily you can collect this chitin from available sources, especially shrimp and crab, shell, and all these. So the main source of this chitin is crab, prawn, shrimp, and krill and squid. So chitin is prepared from chitosan by using simple method. So your chitin containing calcium, protein, then coloring materials, etc. So if we want to remove all these calcium, then protein, so decalcination with dilute HCl, then deprotonation with sodium hydroxide with different temperature, and finally your product may be treated with 0.5% potassium permanganate to remove your colored materials, and followed by oxalic acid. So your chitin is this one. Structure of chitin having a acetyl group, and we have a primary OH group and secondary OH group. As a chemist, we want to remove this, eliminate that acetyl group. What is this process? Is known as deacetylation. How to remove this acetyl group from your chitin? We treat it with this material with sodium hydroxide. So deacetylation with sodium hydroxide, your material become a chitosan, highly very important chemical material. Very important material. We have, as a chemist, I can introduce, I can raise my sound regarding this. We have a primary CH2OH group. We have primary amine. So these two functional groups are highly reactive. So once this chitosan is having some impurities, you may dissolve in acetic acid, then purify with this undissolved substance may be removed. Then acetic acid soluble chitosan may be precipitated with the sodium hydroxide. So you can prepare a purified, highly crystalline chitosan even after treating with your material chitosan with acetic acid. and followed by sodium hydroxide treatment. This is the method that we have adopted to prepare our chitosan from chitin from various sources. Okay. Now, this is an anti-cancer drug, 5-fluorouracil. I want to introduce this within 2-3. Here also we see we have a chitosan. Chitosan is first converted into carboxymethyl chitosan. And you saw what is the modification? That primary alcoholic OH group is converted into a COH group, carboxylic group. So our modified chitosan is actually primary OH group is replaced with this particular treatment, and this treatment is carboxylation. Okay, carboxy. You treat with the chloroacetic acid. So once again, I repeat immediately. You treat with the chloroacetic acid with chitosan. So your product is OH group may be replaced with the COH group. This is the carboxyl group, carboxylated chitosan. Then another one is modified hyaluronic acid. This is also non-toxic. Then we have another material, mesoporous silica, and you see just we have cetyl triethyl ammonium bromide. Triammonium bromide is a surfactant reactive with aminopropyl trioxysilane. This method is available already reported in our literature. And so what is advantages? This seleniated mesoporous silica group. So silane we have NH2 group. Okay, that NH2 group is again abbreviated as this aminated mesoporous silica nanoparticles. Then you keep it here. Okay. What is the earlier one? We have already prepared carboxymethyl cellulose chitosan, where we have NH2 group and COH group. Okay, and what is the advantages of this? I have already mentioned. We want to introduce two different layers with two different charge. And chitosan, modified chitosan, when treated with acid, we have NH3 plus. So here what happens? We have a positive group. Positive charged layer we have, and similarly other part we have considered this hydrouronic acid. We have a COH group. There we have a CO negative group. So after ionization, because even this hydrogen may be abstracted by this CMFC. So we have two different linear chemicals. One is a cationic polyelectrolyte layer prepared by chitosan, carboxymethyl chitosan. The other one is hyaluronic acid. One is positive, the other one is anionic. And the third material is aminated mesoporous silica nanoparticles. Now I come to the point. So we have only three materials prepared from mesoporous silica. We have introduced amino group in mesoporous silica through selenation. Then we have cationic polyelectrolyte layer. Carboxymethyl chitosan, then anionic polyelectrolyte prepared from hyaluronic acid. Now, next slide is sufficient to understand this. So, you take that mesoporous silica, aminated mesoporous silica, treated with these two different layers, different chemicals having different charge. Very simply for understanding this. So, here hyaluronic acid with a positive charge, then carboxymethyl chitosan having a positive charge, the other one is negative. So these two chemicals interact with the mesoporous silica, having an amino group. We have a structure like this, this type of structure that we have. So aminated silica, mesoporous silica associated with hyaluronic acid and carboxymethyl cellulose. So, carboxymethyl chitosan. Then you introduce your drug. Here drug is 5-fluorouracil. So this 5-fluorouracil is introduced in your core structure or even in your layer structures because of this polymer network having two different layers, positive and negative charge layers. So what happens, after loading your drug, what happens, at pH 7, this structure may be damaged, then your drug may be released, and that particular anti-cancer drug 5-fluorouracil is easily leach out from this drug carrier. So I want to conclude this. So what is the advantages of this polyelectrolyte system? So mesoporous silica, amination, amino group you introduce. This amino group may be interact with your carboxylic group of this carboxylic group containing your hyaluronic acid, then interact with amino group, aminated this group. Then finally we have a layer structure, and that layer structure associated with I have this is a good cartoon that we have introduced in our publications. So this after at a particular pH, and this pH is stimuli. Actually, you can introduce a buffer solution with 7.4. So in buffer solution at 7.4, this material may be break, damage, and after breaking, your drug may be released from the drug. Okay, we have characterization of all these. And this paper may be published in this journals. Now, similarly, we have a dual drug system also. We have, then last one, we have introduced. Here we have a layer structure, clay minerals. We have inside this material. We have introduced chitosan modified materials, and again we have introduced a drug, so that drug may be released after pH adjustment of pH or temperature. Like this, we have many different types of material that we have introduced, and finally, we have introduced therapeutic lens with this chitosan, and just like molecular imprinting technology, where we have introduced an image. Here also chitosan treated with acetylation, acetyl chitosan is introduced, and we have a carboxymethyl chitosan is reactive with this material. And this is also a molecular imprinting technology that we have utilized with chitosan modification, acetyl chitosan treated with different types of monomers. Here we have hydroxy methacrylic acid. I want to just to take another one minute for introducing this. This is one of the most important material that we have introduced today. So once again, you come to the point. So this is a chitosan, polysaccharides, acetylation, acetyl chitosan is prepared, then treated with the chloroacetic acid. We have introduced COH group, and finally reacted with the hydroxy methacrylic acid, another monomer, and we have introduced polymerization, and we have a molecularly imprinting polymer with your template. Here template is anti-glaucoma drug, that is a thymolol malate, and this is the drug that we have introduced. You see the drug, this is the drug that we have introduced in cavity of this material, and we leach out this material, this drug in lacrimal fluid, and so that we have create an image, and this is the TML. So we have an image, and we fabricate this lens, and we have fabricated a contact lens, and this contact lens is associated fabricated like this, and this is a lens that we have introduced recently. And this lens is known as therapeutic lens, because this lens containing molecular imprinting polymer associated with your glaucoma drug. And this drug may be this is the different sophisticated instrumental techniques that we utilize. And this I want to conclude like this. Okay, you see the advantages of this lens. Commercially available lens, therapeutic lens. In market is one lens, commercially available therapeutic lens in market is $2,400 for one lens. Now we fabricate material lens from chitosan. After introducing this molecularly imprinted polymer technology, we introduced this drug. And even a single dose is sufficient for treatment of this glaucoma, because this this lens is having a cost. We can calculate that amount of cost of this lens after raising a question from reviewer. So we have calculated the amount spent for fabrication of one therapeutic lens is actually $160. And moreover that, I want to conclude like this. So even now commercially available therapeutic lens, even we need 5 or 6 lens to introduce a minimum amount of drug in our glaucoma anti-cancer cell to treat that glaucoma. So we need for lens, and that lens carry these drugs, and we need 4 lenses. So you just calculate the amount. But what happens in our lens? Our lens is even one single lens is sufficient to leach out, introduce that particular dose of drug, even from single therapeutic. But we need two lens, because even night you can make utilize this already. You after leaching out your drug, you introduce this drug, because that image is there in your lens. So you introduce this your lens in night time in a vessel containing these anti-cancer drugs. So night time that drug may be introduced in your contact lens, and you can next morning you can replace earlier one. Okay, even without lens you can take your bread. So we need only minimum 2 lens. Beyond that we cannot. So even after during your utilization of one lens, you can load the other. You can use other lens for loading your drug in night time, and this is the advantage. So I want to conclude. So minimum we need 2 lens. So how much? 160 into 2, 320. Okay, but still you compare with the value of that 4 lens commercially available now. Anyway, we have published this. Published these findings in our recent journals. Now, Reina, I want to stop here because and we have 2 different types of material that we have. Simultaneously, we introduce 2 drugs in our living organs to treat cancer, and similarly, you can see after surgery, you make utilize antibiotics and a painkiller. So we want to introduce simultaneously 2 different types of drugs in 2 different during surgery, after surgery. So in that way we make utilize this type of a dual drug delivery system, so that we can introduce first we fabricate one particular material having a particular core. You can introduce one drug inside that core. After that you can again polymerize with a new material with a different functional group, and you introduce there a second drug, so that you can make utilize this particular product with a different solvent. Here also we have make utilize different solvent. One is butanol and ethanol, so that you can leach out one particular drug from butanol, and ethanol is leach out a second drug. So simultaneously you can leach out different types of different drugs, especially 2 anti-cancer drugs, or 1 anti-cancer, or antibiotics, or 1 antibiotics, or your analgesic painkiller, or something like that. Okay. Now, okay, I want to stop here because this is ultrasound that we have make utilize. Ultrasound, we have material developed for applying ultrasound drug carrier. You see, one minute. You see here, this is the one drug carrier we have prepared from mesoporous silica, and the advantages of this particular material carry drug. That drug may be leached out after applying an ultrasound, and with a particular frequency externally, so that you can see here we have fabricated a patch. That patch containing a particular drug carrier, and you load that carrier, and we have application of external sound waves that itself is leach out your drug, even in intestine or any anti-cancer organs associated with anti-cancer. So here also we fabricate just like artificial skin and that skin may be that's sufficient to upload loading of this different types of drug, and you apply an external source so that your windows or gate. So we have a gate inside this. That type of chemicals, sensitive chemicals that we have introduced in drug carrier. When you apply that external force, immediately that window may be open, and that through that opening, your drug may be leach out after breaking your carrier. And this is also another fabrication that we have. Then like this, okay. And another, this last, we have introduced photocatalytic catalyst to degrade organic compounds like this. We have fabricated material like this, and this particular material, titanium impregnated material, we have utilize this material for photo degradation of highly toxic dyes or pesticide or that type of chemicals may be dissociated into inorganic compounds. We have diuron is already material utilized to degrade your material like this, okay. And another one, the last one, we have sensors. We have fabricated different types of sensors to identify chemicals and quantify. Simultaneously, we want to identify and quantify biological molecules. And this creatinine. If you identify or quantify creatinine, you can identify the diabetic patients, okay, because so diabetic patients associate with the creatinine. So nowadays, after identifying or quantifying creatinine, the patient may be categorized as a diabetic patient. So identification of creatinine is also very important nowadays. So once you identify creatinine, then you can immediately treatment starts. So here also we have fabricated material from graphite and treated with hydroxymethyl methacrylate. And so what I have concluded is, even we have different types of hybrid material we have prepared through molecular imprinting technology, and here also we have identified creatinine. So sensing, we fabricate an electrode with the glossy carbon electrode. So that electrode may be utilized to quantify and identify simultaneously creatinine or even cholesterol. This is another material is we prepared for cholesterol. And you see, sensor is already okay. Now this is a cholesterol. We have introduced a new material from graphite, and this hybrid material associated with high efficiency to identify and quantify simultaneously this cholesterol, even in presence of other steroids or biomolecules. This is because we fabricate this material with highly selective shadows or image for this cholesterol. I want to stop here. Okay, thank you. So, okay, Dr. Reina.
Sir.
So I want to.
Sir, 1 minute.
Just
okay, Ansha.
Yes, ma'am. Sir, thank you for
just wait.
your enriching presentation. Participant.
I already okay. Now today, just I think
participants, you can
just I take another 1 minute. 1 minute. Okay.
Okay, sir. Okay.
I don't know how because the seminar is actually it's a platform. Okay, we have I don't know in which level students are associated here. Okay, but still I think we have research scholars, MSc, BSc, then students. Okay, I don't know how much that I want to share my this knowledge to younger generation. But still, this type of platform is very important to share our experience, okay, ideas and all this. And this is also my idea. Even now, I have prepared 2,000, sorry, how much? 186 slides. Just imagine, because our anxiety is like that, okay? This transfer of this information, available information within my brain is to younger generation is very important. So even yesterday night itself, I have prepared 186 slides. See, heavy load. How much slides I have only 2025. So the remaining 150 slides are there, okay? But time is limitations are there. But still, wish you all the best. Any questions regarding this? Because nowadays, sharing of experience is very important. And another request for younger generation: you please do research in future, because good teacher always having some research. Then only they have confidence, and you prefer this teaching profession, and also you do some research, especially in your institution. Because Reina Thomas is also who took PhD from my guidance, but I don't know whether further research is facility is not available there. But you have no MSc program there, Reina? No.
No, sir. No.
Okay. Okay. So that is the problem that we have. Anyway, now please. I don't know how much information that you have gained from myself, but still I have concluded like this. Okay, one statement from Nobel laureate: you can live without water and food, even 1 day or 2 days or even 1 month. You can live even week. Okay, 1 week or 2 weeks or months without food and water, but you cannot live even single minute in future without information. This slogan is coming from a Nobel laureate, Roland, who got the Nobel Prize in 1985. I repeat this slogan once again. So the importance of information: you collect the information from available source beyond your readings and learnings. Okay, so beyond that, you collect the information from any available source. You fill your gap. Okay, tomorrow onwards you read more and more now, because nowadays younger generation, they have no habit to read this. Okay, so please, nowadays we have several large number of sources we have available, sources, literature, so journals, and even Google search is sufficient to collect the information. Why not you collect the information? Because you want to fill your gap and become your you raise your sound after getting this information. Okay, fight, struggle, because without struggle and fight you cannot reach somewhere. Okay, and this is also my secret behind this. My secret of energy is not boost, and not boost is not my energy. Information collection is very important. With the information, you can fight with the people. Okay, so information, please read materials and you fill your gap. And knowledge is understanding everything is very important in future. So wish you all the best. And I think this topic maybe you leave it that, okay, but still something that you listen me, okay.
Yes,
so anyway, chemistry, because we chemistry people, okay. Chemistry is very important in our life. You cannot question that chemistry, because everything is understanding. Even in universe, everything is coming from this chemistry, statistical mechanics. We can give an explanation for anything. Okay, we chemist people are in higher level, so that we can propose remedial measures to. There are many challenges we have nowadays. Even global warming ആയിക്കോട്ടെ, പിന്നെ ഓസോൺ ഡിപ്ലീഷൻ ആയിക്കോട്ടെ, എൽനിനോ ഫാക്ടർ, എനർജി ക്രൈസിസ് ആയിക്കോട്ടെ, ഫുഡ് അഡിക്റ്റീവ് പ്രശ്നം, പെസ്റ്റിസൈഡ് പ്രശ്നം, പ്ലാസ്റ്റിക് പ്രശ്നം, even plastic even non-biodegradable plastic is converted into biodegradable plastic. We introduce peroxidants. Okay, so we know within our pocket we have different types of chemicals. So in what type of chemicals that we want to introduce to convert a hydrophobic polymer material to hydrophilic materials, or we can solve what I have concluded. Most of the problem that we face nowadays may be complex tomorrow, or day after tomorrow become more and more complexity. but still we chemist people can solve this problem, all this problem, because everything is associated with chemistry one way or other way. All challenges, all problem may be, all issues may be related to chemistry. Okay, so wish you once again, wish you all the best. So we chemist people can do a lot of things in chemistry. Okay, so we do some research in our future. Okay, wish you all the best, Reina Thomas. Okay, thank you.
Thank you.
Okay.
Sir, your presentation was very wonderful and inspiring. And after a gap of long years, I've been repeatedly hearing this, and it gives us inspiration, or our students get inspiration to go further in chemistry. And if anybody is having any question? Sir, I have a question.
Any questions, you can type it in the chat box.
Okay. Sir, I have a question. You have mentioned about various drugs for anti-cancer treatment and the glaucoma and all that.
Okay.
And how you study the drug activity of these drugs in biological systems or in simulative systems?
Of course, we have cell lines. Publication is only coming after in vitro or in vivo study. We have fabricated material for drug delivery system. Okay, so each drug delivery system maybe we have conducted biological sample studies. Okay, we have collected cell lines, anti-cancer cell line. So each cancer having its own cell lines, and we have introduced this our drug in cell lines, and we have studied cytotoxicity, biocompatibility, then RBC values, counting, everything, you know. Most of the biological, without biological studies, you know, we have confocal, common confocal length and confocal microscopy. Then with the sophisticated instruments, we have studied all these biological studies. We have, you know, we have even we have rat skin. How can you inject your drug through solvent in skin? We have artificial, and that artificial skin may be prepared from rat skin. So our drug may be injected into rats. So we have a biochemistry department, we have ethics committee, we have collect this rat skin after removing hair and flesh and everything. And we have a procedure for that. And with this rat skin, we have make utilized to conduct this experiment, diffusion of drugs in these different layers of this skin. Even otherwise, we have cell lines also. We have a therapeutic contact lens. Okay.
Okay, sir, I have another question that regarding the therapeutical contact lens. Is it patented, sir?
No. We have already published this paper in a high impact factor journal, but still we need modification, because, you know, even we have used this, we have collected this, you know, anti-glaucoma cell lines. That cell line is only we can biological study, and further studies we need to replace, you know, material in a commercial way is very important. Okay. So in that way, we want to again modify this material. This material is not 100%, but still available. We want to compare our efficiency with the only reported material available in commercially or literature. In that way, our material is even now available material compare with the efficiency. Our material having efficient, even cost analysis also we have done. And this, I think, this publication is a high impact factor journal. I could not remember that journal. And you younger students, maybe you just remember that almost all these 200 materials we have fabricated for drug delivery system or therapeutic lens. All these papers, all these materials are already published in even 200 material, maybe 200 publication we have. Very high impact factor journals. Okay, so nobody, because a publication is coming only after repeated question. There are several, maybe 6 or 7 reviewers we have, potential reviewers. They raise question from here and there, maybe 200 question, maybe after sending your paper in publication, and you can answer or you can conduct experiment accordingly what they have raised and clarify everything. Then only publication comes, even cell line, even biological work, even in vivo study, even so without conducting all these studies and sophisticated make utilize this characterization, Once you prepare material, you can characterize the material with sophisticated instruments. Then you apply this material in a real system. Then only your publication comes. Otherwise, the question may be raised by reviewers. Each paper may be, you know these things, okay? Earlier, we have publication is very difficult because 3 to 6 examination will be you multiply by 6, how much questions will be after submission, then again incorporation of the research explanation, then they set another 3 review. This is the process. Publication of a paper in high impact journalist is very, very difficult. Okay.
Okay, sir.
So that is why we need information. After submission your paper, you fight without fighting reviewers. How can you stand? How can you publish? So this is my request to younger generation. Please collect the review information. Fight with the people. Then you become a higher level. Okay. Without fight, you cannot stand. Okay. Wish you all the best.
Okay, sir. Thank you. Thank you so much for your wonderful presentation of your work that has been done over the years. And we have no doubt that this made you to the Stanford list and the BSR fellowship. Ansha, please. And one more thing, I'm very happy that my sir is with us today. And sir usually talk to us as you people sleep for the whole night, but I sleep for only 3 hours on a night. And at this present time also, sir is doing the same thing, and that is how sir is preparing 185 slides in one night. I appreciate. God bless you, sir. We are very happy to have sir with us. Thank you. Ansha, please.
Yes, ma'am. Once again, thank you, sir. Thank you so much for the presentation. I now invite Dr. George, the head of the department, to deliver the vote of thanks.
Today we had a wonderful session by Dr. E. Sanridhar. Actually, I
John, it is not clear.
Not
Sir, clear ಆಗುದಿಲ್ಲ.
The voice is not clear, George.
Hello, sir.
George.
Hello, Miss. Miss.
Okay. Now it is clear. You start from the beginning.
Hello, sir. Hello, sir. Myself, Dr. George PM. Actually, I know you personally, sir. I came a lot of times to Kerala University for conducting the Viva of my seniors as well as my colleagues. I completed my PhD with Dr. MLP Reddy.
okay.
I have communicated with you for so many official things for conducting the Viva. I don't know whether you remember me.
Maybe, okay, sir.
And now here in Marthama College. Sir, today we had such an informative, wonderful and inspiring lecture that can promote even students to young faculties to continue the research. Thank you so much for sharing your valuable time and valuable knowledge to the students and the all present here. Thank you so much, sir. I once again thanks. Thank you for delivering your lecture.
Thank you, sir. Thank you. I am very happy with this. Okay, because my
Okay,
student
sir.
is the principal in your college. Okay, so I am very happy. Okay, wish you all the best, sir. Thank you.
Okay, sir.
We are also very happy, sir, because that much amount of research is going on, and
Yeah.
it is very happy, sir.
Okay.
Okay.
Sir, and then to conduct the I would like our management and our board manager because of his for allowing with a view the 50 in the meeting, and I have gone during the extension of time, but I think they have all attended the completion of the lecture. And thank you, technical support for technical expert Dr. George. I'd like to thank all the members, especially our code and secretary, and all the faculty members once again for supporting us. Thank you.
Thank you.
Thank you.
Okay.
Thank you, sir.
Thank you. Okay. Wish you all the best. Okay. Once again. Thank you.
Okay. And sure.
Thank you, sir. Thank you, sir. And again, I thank all the participants of today's webinar for your cooperation. We'll have our fourth session on 3rd December, 9:30 a.m. Expecting your presence and cooperation there. Thank you.
Reina, thank you. Okay.
Okay, sir. Thank you.
Okay.